Hello, everyone. Thank you for joining our workshop about Ubidots integration with the new The Things Enterprise Tag. I'm Christy, and I make part of Ubidots business development team. This is a follow-up session of our previous talk, IoT and the Rise of the Solopreneur by Agustin Pelaez, our co-founder and CEO. As an intro, I'm going to explain how to build an IoT business from scratch. And later, David, our IoT specialist, will take over for the tech-related side of the integration and Ubidots application enablement platform. So we decided to take on the challenge of creating an IoT business. So we picked a problem to solve, a name, we even bought a domain and designed our logo. And here you have it. So meet Blum Smart Greenhouse, an IoT company helping flower growers do more with less. So in the next 5 minutes, I'll walk you through the process on how to create an IoT business value offer. So, how is a business like Blum born? Here's a very common narrative. So, meet Christy. And it's not me though, but I like that name. So, she was born on the outskirts of Antioquia, Colombia. It's a region which is one of the major flower producers in the world. So, she got the chance to go to the university and she got a diploma in electrical engineering. When she went back to visit her parents, she realized she could implement some projects and install some sensors within their existing greenhouses that were actually small and not very sophisticated. And she could get some data and just give an extra hand. Later, she realized that she could implement the same project with other greenhouses nearby with the small farmers and charge some money. So all of a sudden, she had a business opportunity. But what was the real problem? What's going on with Christie's farm and with other small farmers around her? Cultivation for small farmers in Antioquia is still very minimal. So it turns out to be very labor intensive and inefficient. Also, farmers with years of experience, they probably don't know about these technologies. And without a proper method of data gathering, obtaining the desired crop yields is still a matter of luck. So having experienced these problems in her own greenhouse, Christy decided to create Bloom. From sensors to data visualization and analytics, Bloom is able to deliver data at the farmer's fingertips. And as she kept moving forward, she needed to know some facts and figures regarding how big is the market. So to keep this very top level and just very easy to digest, in her region there are around 800 companies producing flowers with greenhouses, and there's up to 60% that they don't use any sort of technology. So if she gets just the 5% of this market, she could be working with up to like 25 farms. So as a way to test her product and the business in general, she carried out a proof of concept at her parents' greenhouse. And she realized that for every hectare of flowers, uh, 20 devices were needed. And also, a farmer could be willing to pay up to $15 per device. So it's very important to get the costs, right? So in the fixed side, we have Christie's salary, some software licenses such as Ubidots and the Things Industries. And to get to the unit price, we need to know a little bit more about the hardware costs and depreciations and probably some overages and so on. And here we have a graph that, in a nutshell, it indicates that for Christie having a viable business model with cash flow positive financials, she would need to install around 90 sensors. This was a brief exercise we made up. We wanted to be very down to earth and replicable. I hope you're having fun in this whirlwind marathon as much as we are. I'll leave you with David, who would take on the integration of Ubidots and the Things Industries enterprise stack. Ciao!
Hello everyone, and thanks Chris for this awesome intro. I hope you all enjoyed this realistic exercise as a way of encouragement to build up an IoT business on your own. Now, we will go through the process of creating a white label IoT application for the company Bloom IoT that looks just like this. To see how Christy pulled it off, we first need to understand the basic workflow of a LoRaWAN connected IoT application. Connecting your devices to Ubidots using the TTI Enterprise Stack is a four-step process. We will begin using TTI's formatters to translate the binary data to a JSON payload. Then, We will see how to create a webhook to send data to third-party platforms such as Ubidots. Our third step will be creating our own customized API using Ubi functions. And finally, we will store the data in our Ubidots account where it can be visualized by our customers. Following that order, and for the sake of making a real example, the guys at TTI kindly let us use one of their devices, the Things node. This is a starting dev kit with several sensors, including temperature, battery, light, a 9-axis accelerometer, and a push button. A device like this would actually be a good candidate for our smart greenhouse example, as it has light and temperature sensors. Moving forward to payload formatters, these are the workers behind translating the data to a human readable format. From left to right, we have the binary encoded data coming from devices, passing through a decoder function, and ultimately we get a JSON key value object. It is worth noting that TTI Enterprise Stack now implements application-wide payload formatters as well as device-specific formatters. So let's zoom in a bit into this future with an example. The hardware provider, TTI in this case, advises that the binary data frame is a 6-byte long payload distributed into 3 variables: battery, light, and temperature, each one consisting of 2 bytes. On top of that, they also describe the type of each variable. For battery and light, we have a 16-bit unsigned integer, whereas the temperature is the same bit length but a signed integer. At last, to decode the data, one needs to note that the byte ordering is big endian, and wherever the value of temperature is, it must be divided by 100, rendering a float value instead of an integer. Under such premises, a JavaScript decoder for this device firmware data frame looks like this. In line 2, there's a JSON dictionary where we are going to store our values. And from lines 9 to 12, we decode the data using bitwise operation, while at the same time fill up the JSON with the results. At the end, the payload formatter will return a Ubidots compatible JSON just like this. Now, so far we've seen LoRaWAN devices and TTI payload formatters. Let's go to TTI interface and see it in action. From your TTI account, private or hosted, it doesn't matter, we will navigate to the application list and pick the only one available, which is TTI Playground. From this view, actually an overview, one have all of the management tools and settings provided by TTI, but we are only focusing on payload formatters, and to start, application-wide formatters. These can be found in the left panel on the respective option, and then uplink subsection. Here we are presented with a few alternatives: none, JavaScript, gRPC service, and so on. We are selecting JavaScript in this case, and after selecting it, we get an editor where we can input our own code. So I'm doing that. I have it already in my clipboard manager. I just need to paste it and at last save the changes. So far we have already set up the application-wide payload formatter. By the way, I just forgot, but in this GitHub repository from the Things network called Arduino Nodelib, you can find both under the examples and then basic, you can find the firmware for the Things node and this decoder written in JavaScript. Now back to TTI, we are only left with device-specific formatters. These can be found in the left panel, here on the devices option, and we see all the devices available in the application. I created a dummy one called TTIPconf, and if I click on it, I will find its information. And in the payload formatters tab, we will find the same UI as before. So let me just replicate what we did with the payload, with the application-wide formatters, and click in JavaScript. We get the editor, and copying from the clipboard manager, we'll have the same result here. So I will save the changes, and we are ready. So before heading back to the presentation, there are two important tips to note. One is that up to this point, we are decoding the data coming from devices into an Ubidots compatible JSON. And secondly and foremost is that device-specific formatters take precedence over the applications. This means that if there's a device decoder in place, it will be run instead of the applications every time the device sends data. With that being said, the final steps before embarking ourselves into Ubidots application builder platform are webhooks and Ubi functions. In terms of webhooks, they are simply an HTTP request to exchange data from a client to a server. In the scenario herein, TTI stands as the client while Ubidots as the server. However, to exchange data, both parties need to talk the same language, and I mean the format. Here's where Ubidots become important. This is a functions as a service model where we can code our own APIs either using Python or Node.js. And given TTI's native output is not compatible with Ubidots, we will parse it and make it compatible within a function. So what better way than actually doing it? Let's go back to TTI and now Ubidots to both create a webhook and an Ubi function to wrap up our integration process. So here again, we will navigate the left panel to find the integrations dropdown and see that there are a few options: MQTT, webhooks, and PubSubs. As you expect, we are going to select webhooks. There are others already, but I'm going to create a new one by clicking the Add Webhook button in the top right corner. This is again a four-step process. We will begin entering our webhook ID, selecting a webhook format, and for the third and fourth steps, we will enter the information related to the HTTP endpoint where we are going to send the data. So let's begin. Webhook ID is going to be TTI-bconf. Webhook format is JSON, and for the base URL and uplink message path, we first need to create our custom API endpoint using Ubi functions. So let's stop here and do that. Within your Ubidots account, Ubidots can be found in the devices menu and then the functions option right here. From this point, we're going to create a new one clicking the plus button in the top right corner. And we are here. So this is Ubi functions development environment. We have in the middle the code editor and in the left panel some basic information. To continue, we are going to put a name to our Ubi function, in this case TTI-bconf. Select the HTTP method upon which this function is going to be triggered, and in this case, it's going to be a post request. And then, if you remember, we can select our runtime to be Node.js or Python. I'm doing Python 3.6. Now, the coding part. Here in the editor, I'm going to select all of this and delete it and paste my own function, which I have in the clipboard. If we have a close look, here on line 6, we need to input a token, an authentication token from our Ubidots account. You can find one in the avatar dropdown on the API credentials. So copy it, paste it, and before we launch our custom API, I would like to show you how TTI native JSON looks like and why we need to parse it. So to that end, I'm going to open a JSON viewer like this one and paste sample I have in the clipboard as well. To see it big, we just need to process it and enlarge it. So we need two things from this JSON, which is not compatible with Ubidots. One is device ID, which is in this key and device IDs under the device ID. And then we need to extract our JSON object coming from the payload decoders, and that can be found in the uplink message and then the decoded payload. If you have a close look, it is an object, a key value object, containing our variables and the respective values. Here I have battery and its value, light and its value, and it's the same with temperature and its value. Okay? So that is what we need to extract from this. In the function, in line 13 and 14, we take the payload coming from the payload formatters, and then we extract device ID in this line. At the end, on line 19, we simply post the data using HTTP again to your Ubidots account. So before getting back to TTI, we need to launch our Ubi function. That can be done clicking in the Make It Alive button and then clicking here OK. If you notice, we already have our HTTP endpoint URL. I'm going to copy it and go back to TTI. So here in the base URL, I'm going to paste it, and please note something. I need only to paste the host, that is parse.ubidots.com. So I will lose the path, cut it, and guess what? We need to enter it here in the uplink message as the path to the endpoint. Now that we are ready, just add the webhook, and we have completed the integration. Next step is going to Ubidots and check if we are getting data coming from TTI and if there's a device already created. So here to find the devices, I'm going to click again on the devices menu and in its namesake option. As we can see here, we have already a device created. It is called the Things node. If I click on it, I can see the variables. And again, if I click on one variable, I will see the historical data we've been collected from the Things node back in Amsterdam from the last few days. So I know I told you that we had already created and completed the integration, but this is actually the proof that we are getting data from the devices, passing through TTI tools, and then getting to Ubidots, where we can start building your IoT application, which is going to be the last section. So for the time being, some kudos and confetti. There you go. So back to the presentation. So Ubidots Application Builder. Here's where things join together to build a data-driven application and business. Ubidots front-end and back-end toolkit allow Christy to build her own customized IoT application, including visualizations to consume the data, device and user management, and as well as you are seeing right now, the ability to brand her application's login portal to Bloom's look and feel. To see how she did it, we will do three things within Ubidots. Create a dashboard and widget to plot data. Second, interact with the app's customization. And finally, create an end user and log into Bloom's application as this user. So let's get started and go to Ubidots. So from here, we will navigate the data menu and select the dashboard option. I already created one. It is called Greenhouse. So we are only left to create, let's say, a line chart to plot historical data. It's easy as looking for the variable we want to plot, in this case from the things node, and I'm selecting temperature. I'm going to leave all the other settings just as they are and click OK. As you can see, this is how it plot data within Ubidots, and this widget shows us the historical data of temperature. It also responds to the daytime picker over here. So if I select, let's say, last 30 days, I will see the data accordingly. As you can see, we have been receiving data from the things node for quite a few days now because the TTI guys kindly let us use it. Anticipating that we wanted to see a more robust dashboard, I created another one called Orchid's Greenhouse. This one have an image widget, a map widget showing the location of our greenhouse, and as well as the sensor battery, light switch, the last reading from the temperature, and here again, the historical data from temperature. This dashboard also responds to the general daytime picker. So I'm going to select here previous week and just verify that it works. So now we have seen how to create widgets and dashboard within Ubidots. Let's go to the apps section and see how customization works. Here we have the different applications. In this case, I only have one, but please note that we can have more than one. To edit it, we are going to click here on the pencil and we get a few subsections. I'm only focusing on domain and branding, starting with branding. Here you can see the options in terms of look and feel. You are able to input the header logo, the login screen, background image, and this option for the loader logo and favicon. Of course, we cannot miss the color palette to change all the colors within the application. Equally important to note is that on the right side here, we have a few previews that allows us to, let's say, see upfront how the application will look while we are changing it. So I'm going to show you here, changing the header color. I'm copying this one before to a red one and see how it changes, right? So this allows you to actually see how it's going to look and you don't have to go enter as a user to check it out. So the other section, and it is really important, is the domain one. As Christy told you, and I'm talking about our Christy, we both a domain to Bloom's IoT application. It is called bloom-iot.com, and we created a CNAME record, and you can think it as an alias to this Ubidots subdomain. All applications in Ubidots have an Ubidots subdomain following this structure. Something that ubidots.iot.ubidots.com, and our alias just brand that subdomain and points to portal.bloom-iot.com and allows us to access our application from this domain. So let's see that. As we expected, this is Bloom Smart Greenhouse login portal customized to Christie's look and feel. So let's go back, and we are only left with one thing, that is creating a user and accessing the application from this user. This can be found in the users dropdown under the respective option. Now I already have one, but let's go to the process of creating a new one. I'm going to input a name, a username, and just a dummy email address. Then I need to select the organization, and this is actually the way Ubidots allows you to segment your business into different customers. So for example, I have Tulip Greenhouse, and in the next step, I will be able to select the permissions this user will have. I will give it all permissions to create, delete, and change resources assigned to this user. That is the manager role. At the end, I'm going to skip this step. That is just an invitation email. But for the case hearing, we don't need it right now. Now that we have this user, I'm only left to assign a password, an easy one, and then we can go to the application and see how this David user will actually look the application. So David here, the password, and let's sign in. The difference is pretty obvious. All the colors have changed, and you see the banner different, the logo, and here on the navigation bar we only got two options, the devices dropdown and the data dropdown. If we compare with the administration side, I'm going to change the tab right here, you can see that here we have users and applications. Now, very important to note is that if I go to the dashboard list, you can see that there is only one. We are missing the greenhouse dashboard, and that is because that dashboard is not assigned to the organization. So David user cannot have access to that one. Here you have, if I assign it to the tulip greenhouse organization and go back to David's, I will reload the page. And in this case, open again the dashboard drawer. And here it is, the greenhouse dashboard. This means that each customer has each several resources, including devices, dashboard, events, but in this case, I only have this one. So guys, up to this point, we have built the grounds of an entire IoT business using the TTI Enterprise Stack and Ubidots application builder. So to that, some confetti again, celebrating that we achieved these results. Finally, I thank you all for tuning in to our workshop. I hope you all enjoyed Chris's exercise as well as this integration process, and now that you know how to do it, let your IoT solution ideas be a reality. Keep enjoying this LoRaWAN marathon, and of course, stay safe, stay home.